Welcome to the material session of Pulsar's Career Point. This is a video for the student of class 12 on Unit 2. The name of the unit is Electrochemistry. This is the part 7 video of this unit covering the topics Kohlrausch law and its application. আমি ভিডিওরে Kohlrausch law আর তার application কথা পড়িবা। Now let us come. What is Kohlrausch law? At infinite dilution, the equivalent conductance of the electrolyte is equal to the sum of their individual contribution when all these ions migrate independently. Infinite dilution le electrolyte ro समस्त ions ro individual contribution for the electrolyte ro sum ko ame kahiba tar equivalent conductance bola. Thus, the equivalent conductance at infinite dilution is equal to the sum of ionic conductance of its component ions. That is, equivalent conductance of the electrolyte is equal to the equivalent conductance of cations plus equivalent conductance of anions. Here, lambda 0 cations and lambda 0 anions are the ionic equivalent conductance of cations and anion respectively at infinite dilution expressed in ohm inverse centimeter square gram equivalent inverse. Now, application of Kohlrausch law. First application is calculation of equivalent conductance of the electrolyte at infinite dilution. Equivalent conductance of an electrolyte cannot be obtained graphically by extrapolation, but indirectly it can be evaluated by applying Kohlrausch law from the knowledge of the equivalent conductance of the strong electrolytes. Example, equivalent conductance of acetic acid at infinite dilution can be calculated from the equivalent conductance at infinite dilution of HCl, NaCl and C3CON, that is sodium acetate, as below. Equivalent conductance of acetic acid is equal to equivalent conductance of acetate ion plus equivalent conductance of H plus ion. This is according to Kohlrausch law. Again, for H plus, with H plus we can add equivalent conductance of Cl minus, and with equivalent conductance of acetate ion we add equivalent conductance of Na plus, and subtracting again the equivalent conductance of Na plus and Cl minus. आमको सजे देवा को पड़िबो एसिटेट आयन सहित Na प्लस को मिसी देवा को पड़िबो, H प्लस सहित Cl माइनस को मिसी देवा को पड़िबो, एवं जो Na प्लस और Cl माइनस को आम एडिशनली एड कलु ताको माइनस कर देवा को पड़िबो. By combining this, we can write down equivalent conductance of acetic acid is equal to equivalent conductance of HCl plus equivalent conductance of sodium acetate minus equivalent conductance of NaCl. Thus, from the knowledge of the equivalent conductance at infinite dilution of HCl, NaCl and sodium acetate, the equivalent conductance of acetic acid can be calculated. Another example, equivalent conductance of ammonium hydroxide at infinite dilution can be calculated from the equivalent conductance at infinite dilution of ammonium chloride, sodium hydroxide and sodium chloride as below. Solution kariba. Equivalent conductance of ammonium hydroxide is the sum of the equivalent conductance of ammonia ion and equivalent conductance of hydroxide ion. Now, equivalent conductance of ammonium ion सहित Cl माइनस को ऐड कर दबा, OH माइनस सहित Na प्लस को ऐड कर दबा, एडिशनली जो Na प्लस और Cl माइनस को ऐड करो ताको सब्सट्रैक्ट कर दबा. Then combining or pairing this we can get equivalent conductance of ammonium hydroxide is equal to equivalent conductance of ammonium chloride plus equivalent conductance of sodium hydroxide minus equivalent conductance of NaCl. Thus, from the knowledge of equivalent conductance at infinite dilution of ammonium chloride, sodium hydroxide and sodium chloride, the equivalent conductance of the weak electrolyte ammonium hydroxide can be calculated. Now, application of Kohlrausch law, second application, calculation of degree of dissociation alpha and dissociation constant Kc of weak electrolyte. The degree of dissociation alpha of weak electrolyte can be calculated by measuring the equivalent conductance lambda of the solution of the electrolyte at any given at, at any condition, and lambda 0 value thus obtained at infinite dilution. Then we can calculate the degree of ionization or degree of dissociation alpha is equal to lambda by lambda 0. From the knowledge of the concentration C and the degree of dissociation alpha, the dissociation constant Kc can be calculated as follows. Kc is equal to C alpha square by 1 minus alpha, which is equal to C alpha square, as 1 minus alpha is nearly equal to 1, as alpha is very less than 1. Now, application number 3, calculation of solubility of sparingly soluble salt. The solubility of sparingly soluble salt can be calculated from the knowledge of specific conductance K and molar conductance lambda m of the weak electrolyte as follows. That is, solubility S is equal to K into 1000 by lambda m. Problem: the specific conductance of decinormal solution of NaCl is 0.0092 ohm inverse centimeter inverse. If the ionic conductance of Na plus and Cl minus ions at same temperature are 43 and 65 ohm inverse centimeter square gram equivalent inverse respectively, calculate the degree of dissociation of NaCl solution. This problem comes in annual higher secondary examination 2009. Now let us come for the solution of this problem. Here the specific conductance K is given at 0.0092 ohm inverse centimeter inverse, and normality N is given as 1 by N, that is 0.1. Now lambda equivalent conductor lambda EQ is equal to K into 1000 by N, putting the value of K at 0.0092 and N at 0.01. The equivalent conductance can be calculated to be 92 ohm inverse centimeter square gram equivalent inverse. Again, according to Kohlrausch law, equivalent conductance of NaCl is equal to equivalent conductance of Na plus equivalent conductance of Cl minus. That is, equivalent conductance of Na plus is given 43 and Cl minus is given as 65, which is found to be 108 ohm inverse centimeter square gram equivalent inverse. So lambda is equal to lambda EQ by lambda, that is 92 by 108, that is equal to 0.85 or 85%. Hence, the degree of dissociation of NaCl is 85%. Now, let us come for another problem. 0.05 in NaOH solution afford a resistance of 31.6 ohm in a conductivity cell at 298 Kelvin. If the cell constant of the cell is 0.376 centimeter inverse, calculate the molar conductance of NaOH solution. This question come in annual higher secondary examination 2011. Let us come for the solution. Here molarity M is equal to 0.05 m, resistance R is equal to 31.6 ohm, and cell constant is equal to 0.376 ohm inverse. We know that specific conductance K is equal to observed conductance into cell constant. Observed conductance is the reciprocal of resistance. So K is equal to 1 by R into cell constant. Here R is given 1 by 31.6 into cell constant is also given 0.376, and the value is calculated to be 0.0119 ohm inverse centimeter inverse. Again, molar conductance is equal to K into 1000 by M. K is calculated to be 0.0119 and M given as 0.05. Putting these values, the value is calculated to be 238 ohm inverse centimeter square mole inverse. Thus, the molar conductance of the solution is 238 ohm inverse centimeter square mole inverse. Let us come for the another, which is common in annual higher secondary examination 2016. The equivalent conductance at infinite dilution of ammonium chloride, NaOH and NaCl are 129.8, 217.4, 108.45 ohm inverse centimeter square gram equivalent inverse respectively. Calculate the equivalent conductance of ammonium hydroxide at infinite dilution. Let us come for the solution of this question. The equivalent conductance of ammonium hydroxide at infinite dilution can be calculated from the equivalent conductance at infinite dilution of ammonium chloride, NaOH and NaCl as below. That is, equivalent conductance of ammonium hydroxide is equal to equivalent conductance of ammonium ion plus equivalent conductance of OH minus. Now by adding equivalent conductance of Cl minus to ammonium ion and Na plus equivalent conductance of Na plus to equivalent conductance of OH minus ion, and then subtracting both, we get this equation. Now by pairing this, we can write down equivalent conductance of ammonium hydroxide is equal to equivalent conductance of ammonium chloride plus equivalent conductance of sodium hydroxide minus equivalent conductance of sodium chloride. Putting these values, the value is calculated to be 238.75 ohm inverse centimeter square gram equivalent inverse. Now, another problem which is come in environment secretary examination 2018, the equivalent conductance at infinite dilution of sodium acetate, sodium chloride and HCl are 78, 109 and 384 ohm inverse centimeter square gram equivalent inverse respectively. Calculate the equivalent conductance of acetic acid and infinite dilution. This question come in HSC 2018. Let us come for the solution of this problem. That is, equivalent conductance of acetic acid at infinite dilution can be calculated from the equivalent conductance at infinite dilution of sodium acetate, NaCl and HCl are below. Equivalent conductance of acetic acid is equal to equivalent conductance of H plus ion plus equivalent conductance of acetate ion. Now by adding equivalent conductance of Cl minus to equivalent conductance of S plus and equivalent conductance of Na plus to equivalent conductance of acetate ion, and then subtracting both the equivalent conductance of Na plus and Cl minus. Then by pairing them, we get equivalent conductance of acetic acid is equal to equivalent conductance of HCl plus equivalent conductance of sodium acetate minus equivalent conductance of NaCl. By putting the given values, the value of the equivalent conductance of acetic acid is calculated to be 353 ohm inverse centimeter square gram equivalent inverse. Thanks for watching Gopal Sir's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.